Okay, sorry about that. Got cut off. So our parent function then shows us, let me get my pen back here. So our parent function, you'll notice we have the same values in our x column and our f of x column. So let's graph this, and we'll graph it on both of these graphs because we want to compare both of these functions to the parent function. So starting at the origin, I'm going to graph -2, so left 2, down 2. My next point is left 1, down 1. Then I have the origin, 0, 0. Then I'm going to go right 1, up 1. And then I'm going to go right 2, up 2. Right, so this is my parent function. You can see straight line, so it's a linear function. Very basic, goes through the origin. So I'm going to replicate this over on this graph. And I'm going to label these f of x equals x. That's the name of this line. F of x equals x. All right, now that we've got that, and you saw how to make the table, I'm going to erase that so we have room to make a table for the other functions we want to graph so that we can compare them with the parent function. So let's scroll back up just a tad. So on part A over here, I'm going to graph g of x equals x plus 2. So I again am going to make my table. It'll let me write. X and g of x are my two columns in my table. And I'm probably going to do the same values. -2, -1, 0, 1, and 2. Okay, so I'm going to substitute into my function that I can no longer see, so I'm going to rewrite it down here to help myself out for right now. And then we'll erase it when we graph. So if I'm substituting -2 in for x, then -2 plus 2 is 0. Now I'm going to substitute -1 in for x. -1 plus 2 is +1. Next, I'll substitute 0 in for x. So g of 0 equals 0 plus 2, which is 2. Now I'm going to substitute 1 in for x. 1 plus 2 is 3. Finally, I'll substitute 2 for x. 2 plus 2 is 4. So these are my coordinates. -2, 0, -1, 1, 0, 2, and so on. So let's clear our graph space and go up and graph these. Okay, so I'm going to graph this in blue so we can see the difference. So my first point, -2, 0. So from the origin, I go left 2 and up 0. So we can already see a different starting point for my graph. My next point is -1, +1. So from the origin, go left 1, up 1. Not to be confused with slope, remember our coordinates are always x and then y, which is the opposite of slope, which is y over x. So my third point is 0, 2. So from the origin, I go over 0 and up 2. My next point is 1, 3. So I'm going to go right 1 and up 3. And finally, I have 2. I'm sorry, we put 2, 2 in our table, but I should be substituting +2 into the equation. And +2 plus 2 is 4. So let's fix that. That's the great thing about linear functions is we can see our patterns. So when we make a little mistake like that, we can see it and fix it. So that's always a good clue that something wasn't right. And you all were probably thinking that the whole time I had that written. That's where I need you. Okay, so let's connect these. And now let's look at some of the things that are the same. We're comparing these graphs. So really very similar. And let's go ahead and label. Oh, why does it keep jumping on me? Okay, so this, oh my goodness. Let's try this. This blue line is, we're going to get it g of x equals x plus 2. So one thing I noticed is that these lines appear to be parallel. So think about how we can check for sure. We know that parallel lines have the same slope. So as I look at my parent function, my coefficient of x is 1. And in my g of x function, my coefficient is also 1. So they are indeed parallel. That's one way they're the same. The only thing that's really different is g of x has a y-intercept of positive 2, where f of x has a y-intercept of 0. So otherwise, these graphs are identical. So all that we changed was we took this line and shifted it up 2 units. So let's check out on part B how this graph is similar and different. So this time we're going to graph p of x equals negative 1/3 x. So let's make our table of values. So we have x and p of x. Again, I'm just going to do -2, -1, 0, 1, and 2. I can see I have room for that on my graph. So as I substitute -2 into this function for x, -1/3 times a -2 is going to make a positive, and this is going to give me positive 2/3. As I substitute -1 into my function, -1/3 times times -1/3 makes positive 1/3. When I substitute 0, I get 0. When I substitute 1, -1/3 maintains its identity. And when I substitute positive 2, a negative times a positive makes a negative, and I get negative 2/3. So let's look at graphing this in comparison to my parent function. So my first point is -2, so I'm going to go left 2, and then I'm going to go up rather 2/3. My second point, -1/3, so I will go left 1 and up 1/3. Then I have the origin, 0, 0. My fourth point is 1, -1/3, so I'm going to go right 1 and down 1/3. And my fourth point is positive 2, -2/3. So I'm going to go right 2 and down 2/3. So we can see this graph as try to get a straight line going through there, actually looks quite a bit different than our parent function. So let's think about why as we compare these. So let me scroll back up for us. So this is, I did it again. P of x equals -1/3 x. So we'll name that line so we know what we're looking at. And as I look at these, I see my parent function has a positive slope. It's sloping up from left to right. And I know that's true because I have a positive slope of 1. However, p of x has a negative slope, which is why it's going down from left to right. So that's a difference. One similarity is they do have the same y-intercept. So really the only thing we've changed from our parent function to p of x is the slope. We've made it negative and we've changed it to rise 1, run 3. So that gives us not quite as steep of a line, and it's also sloping down. So that's the idea behind parent functions. Let's wrap up with a real world problem and check out the movie tickets. So the average price of a movie ticket in the US from 1980 to 2000 can be modeled by the function f of x equals 0.10x plus 2.75. X is the number of years since 1980. So as I read that, I'm thinking, all right, let's go ahead and label our x-axis then. So this is number of years, and not total, but just the number of years since 1980. So my function is helping me compare the number of years since 1980 to price. So here I'm going to put average price in my best sideways handwriting, which wasn't very good. Okay, so now we need to graph the function and identify its domain and range. And I'll tell you, this part is going to have a new element to it that we haven't practiced a lot yet. You know the domain are x values and the range are y values, but in this type of situation, we're going to have a specific way we name that. So let's graph this. So here's my function. So I'm going to make my f of x table. So here's where I'm really naming my domain. I'm picking my x values. So as I look, usually I'll do a couple negatives, 0, and a couple positives. But it doesn't make any sense to do negatives here because I'm trying to look at the years 1980 to 2000. And my x-axis is telling me how many years I am beyond 1980. So we are going to start with 0 as our smallest x value. So for that reason, I'm just going to start at 0 and do the first 5 numbers. So as I substitute 0 into f of x, oops, I'm sorry. Gosh, you guys, this is where I need you to be here to tell me when I'm underlining the wrong thing. Okay. Here is our function. That was a separate part. So our function says f of x equals 0.10x plus 2.75. So if I put 0 into my function for x, then this cancels to 0 plus 2.75. Want my pen? So that gives me 2.75. As I substitute 1 in here, 1 times 1/10 is a tenth plus 2.75 is 2.85. And since I know we're talking money here, I'm just going to refer to it as money. So we have $2.85. If I put a 2 in here, that gives me 20 cents plus 2.75 is $2.95. If I substitute 3 in, that gives me 30 cents for a total of $3.05. And if I substitute 4 in here, 4 times a tenth is 40. And 40 cents plus 2.75 is $3.15. So best case scenario is really I would have graphed all the way up to the year 2000. But since my scale was already listed on this graph, we're just going to look at these couple years here. So let's plot these points. I'm going to go over 0 and up 275. Then I'm going to go over 1 and up 285. Then I'm going to go over 2 and up 295. Then I'm going to go over 3 and up 305. And then I'm going to go over 4 and up 3 and 1500. So not my most precise plotting, but we kind of get the idea. Now here, I'm not going to put an arrow on this end. And the reason why is because we said it doesn't make any sense to look at years before 1980. And since my x-axis is telling me years since 1980, this is truly going to continue until I get all the way up to the year 2000, which really, this would be 1981 because it's 1 year since 1980, 1982, 1983, 1984, 1985. So this graph would really continue here. Now, if I were to graph this all the way to 2000, then what my domain would look like, so I'm going to use D to represent my domain. So my domain would be all of the numbers from 0 up to 20, right? So the way I write that